Hey everyone, welcome to episode 4 of Everyday Physics. Today we're going to be looking at motion maps, which are a great tool for modeling basic motion. The idea of a motion map is that you can see if the velocity of an object is increasing, decreasing, or remaining constant by marking its position every certain unit of time, usually in seconds, and that way seeing if the gaps in between the markings are getting bigger, smaller, or the same. So I'm going to have my brother Ben walk and drop beanbags every second, first at a constant velocity, then an increasing, and finally a decreasing velocity. As you can see, the markers are pretty evenly spaced, indicating that he was moving at a constant velocity. Now we see that he started here, and the distance between the first and second is significantly smaller than the distance between the second and third, which is smaller than the distance between the third and fourth, which shows that he's speeding up. He started at rest, as we see they're very close together, and then as he moved along, he gained velocity, and they get further apart. Now we can see that he started here with a relatively large velocity and moved this way. And as we move along, the beanbags get closer together, indicating that he was moving with a decreasing velocity. I went ahead and drew out the 3 motion maps that we did outside on paper. This is constant, increasing, and decreasing speed. So a motion map will always have an axis, sometimes labeled with distances, sometimes not. And then the dots or markers every second, with arrows in between them. And it'll always mark t equals 0, which is where the object was when time started. That doesn't always happen to line up with the position, 0 meters, but in this case it did. On the constant velocity diagram, we see the markers are equally spaced and the arrows in between them are also equal length, which shows that it's a constant speed all along. If we look at the increasing speed one, we see that the dots start close together and get further and further apart, and the arrows get longer, indicating that the speed is increasing as it goes. And then on the decreasing speed one, we see that the arrows start long and get shorter, and the spaces in between the dots get smaller, indicating it's decreasing. I have one more example here that I made up to sort of round things out. So in this example, we see the object starts at t equals 0 at 0 meters, and then as we move to t equals 1, 2, and 3, the dots are getting further apart and the arrows are getting longer, which means the object is speeding up. And then as we go from t equals 3 to t equals 4 to t equals 5, we see that the arrows are getting closer together again, indicating that it's slowing down, the speed is decreasing. At t equals 6 and t equals 7, we see that there's no arrow at all, the object is not moving. And we simply move these up so that we don't overlap the arrows. At t equals 8, we see that it has another arrow, and then at t equals 9, we see it gets longer and longer as it goes to 10 and 11, indicating that it's speeding up again, this time in the other direction. And that's basically it. There's not much more to motion maps, so if you understood everything I said, you should be good to go. Thanks for watching. Hopefully this helped you understand motion maps, and I'll see you next time.